Organic materials. Organic materials basically are polymers and wood. We are going to check the definition of polymers. Polymers are defined as macromolecules composed of one or more chemical units, one or more monomers. Those monomers are repeated like a chain. The monomers are the chemical unit that are repeated through the chain of the polymer. Yeah, the monomer is the basic cell and is repeated to create polymers. A good example is wood. Wood is basically a polymer of cellulose. Cellulose is the main component of the polymer, and wood is a perfect polymer. It's a natural polymer. And those cellulose are connected together with a lining, and lining is basically the glue to connect those monomers. Classification of polymers. The polymers are classified like natural and synthetics. In natural polymers we have great examples: rubber, cellulose, and proteins. In synthetic polymers we have an example: polypropylene and polyvinyl. Those are great examples of synthetic polymers, naturals and synthetics. Now we are going to analyze the internal structure of the polymers. The polymers are basically chains of monomers, and they are bonded together in order to create the polymer, the chain. The monomers are single molecules. For example, hydrocarbons. Hydrocarbon is a single monomer. Or amino acids. The amino acids is the structure of a big polymer. The process when you connect different monomers to produce the polymer is the polymerization. Polymerization is the procedure to connect monomers in a chain. Monomers are the building blocks of more complex molecules or polymers. Polymers consist of repeating molecular structures usually joined by covalent reactions, non-permanent, covalent. Example of monomers and polymers. For example, glucose, fructose, and galactose, those are monomers. And polymers are lactose, maltose, saccharose, those are examples of polymers. There are two types of polymerization. There are processes that produce water at the end, and a process of polymerizations where you need added and other external element. Condensation polymerization, in which the chain growth is accomplished by elimination of water. That's very common. And addition polymerization, in which the polymer is formed without the loss of other material. There are many variants of subproducts of polymerization reactions. Okay, don't forget we have addition polymerization, and we have condensation. Normally the condensation polymerization produces water or hydroxide of chlorhydric carbon. Okay, we have those type of polymerizations, condensation or addition. Examples, we are going to analyze example of condensation polymerization. We have dacron, polyester. Polyester is a great example. Dacron is a trend made for a polyester fiber. Yeah, nylon. Nylon is another great example of condensation. They are used for a variety uses of clothing, furnishing, in industrial uses. You remember we have the straps of the travel leaf. The straps of the travel leaf in nylon. Nylon is strong. Bakelite. Bakelite commonly used in breakers, in electrical insulators. All electrical switches and the insulators of high tension connectors, high tension switches, high tension switch selectors. Bakelite is a castable fire resistant plastic. Yeah, it's used like an isolator in electrical device. Yeah, it's commonly used. And proteins. Proteins by itself is polymers of amino acid. The monomer of the proteins are the amino acid. Yeah, the amino acids are the monomers of those proteins. We are going to start basically with a fiberglass. A fiberglass is not as strong like a carbon fiber, but it's great. It's great and is used in different type of applications. Fiberglass is a non-conductor. For that reason, fiberglass is used like an insulator, isolator, and is invisible to the majority of the transmissions. It's a good choice for electrical fabrication of electrical components and broadcast application. It's excellent. Yes, depending of the resin, you have different structures. You can cover it the fiberglass fibers with a polyester resin and also with epoxy resin. With both of them, with the polyester and with epoxy. With both of them, you can cover the fibers in glass. Yeah, and the result is wonderful. It's magic. Yeah, and we are going to check right now other properties of fiberglass. It's an elastic solid. Carbon fiber is more elastic in comparison with the fiberglass. It's based on silica, remember, and is extruded in small fibers. In some cases, those fibers are twisted to create a yarn. That's the typical structure of a fiberglass. It's a good thermal insulator because have a low thermal conductivity. It's weak in tensile strength in comparison with the carbon fiber, but it's enough and is more ductile. And in comparison with carbon fiber, glass have a more elongation before it breaks. Let me I check that structure. Look at this. This is the situation of fiberglass with a polyester resin or with epoxy resin. And this is the difference. This is the maximum Young's modules of fiberglass mixed with the polyester resin. This is the point number one. And this is the Young modulus when you have a fiberglass covered with epoxy resin. Yeah, with epoxy resin you reach higher Young's modulus. Now we are going to analyze the different type of fiberglass used in marine, automotive, aviation industries. And we have a glass, is alkali glasses, the number one. Alkali glasses is a good chemical resistance, but have a lower electrical properties. The C glass is the chemical glass, have a great resistance to chemical products. The E glass is excellent for electrical purposes because it's an electrical insulator and resists the attack from water. For that reason, is used in marine application, the E glass, and also the S glass because it's an excellent in structure. The S glass, structural glass, is used for your excellent mechanical properties. Both of them are used in marine applications. And the D glass is a dielectric glass, have the best electrical properties, but have a lacks of mechanical properties in comparison with E and S glass, commonly used in marine applications. Properties of fiberglass. Fiberglass is a great thermal insulator, is a great electrical insulator, is good for reinforced, is good for temples, for sound absorption. For that reason, is commonly used in residential application for the fiberglass, the insulator that you have in the roof in your home. Insulator for sound, insulator for temperature. Yeah, it's excellent in strength. It's used in automotive. It's used in the fabrication of holes and in the fabrication of electrical insulators like breakers and switches and other electrical devices. Yeah, this is the foam used in your home. That one. Be careful because this is only for insulation of sound and insulation of temperature. It's different like the structural foam used in marine application. The structural foam used in the reparation of ball heads, stringers, and transoms of carbon fiber. Carbon fiber or graphite fiber is a material consisting of extremely thin fibers in between 0.005 and 0.01 millimeters. Is practically a hair. Is it too thin? The carbon atoms are bonded together in microscopic crystals. Remember that the carbon atoms, depending how they are organized, produce the most strongest surface on the Earth is the diamond. The diamond is basically pure carbon. Incredible, no? And the graphite that is used for like a lubricant is also carbon molecules. Incredible how the depending on what? Depending on how is organized the atoms of carbon and depending of the pressure and the temperature. Yes, for that reason you found a different type of diamonds with different colors. Yeah, but the most famous is the completely clear, transparent diamond. This is considered a pure diamond. Remember that the synthetic diamonds produced on the laboratory, they have like a blue appearance. It's produced on the laboratory. It's hard, but the appearance is a little different, like the natural diamond, completely transparent, completely clear. Yeah, depending how is the organization of the atoms, you have a complete different structures with the same element, carbon. Carbon is magic, exactly like a silica. Silica is magic, and iron. You remember iron? How magic is iron? Depending, depending of how is the alloy, you obtain different steels, different cast irons, and also iron by itself is magic because it's magnetic. Yes, this is the unique metal with those properties because iron is that we have electricity, because iron is that we have the telecommunications, the internet, the majority of those wonderful, wonderful tools that you have in your hands today. Magic elements, carbon and iron, both of them are excellent. The Young modulus of carbon is magic. Let me explain what is the meaning of that. You remember this definition? This curve, the curve of strength versus deformation, and this is the curve. This is the curve, and this is the maximum Young modulus, that point. And this is the area here in this side is the elastic area. This is the elastic area. And the area over there in the green area is the plastic deformation. In other words, this is the point of reference. This is the point where the material passed from the elastic area into the plastic area. What is the meaning of that? Elastic area is the area where you can deformate the material and the material return to the original position. In the plastic area, when you deformate the metal, after that point, the material stays deformated. This is the point of reference, the point where the material passed from the elastic into plastic. Yeah, and this is the break point. This is the point of fracture or break point. This is the typical curve that we analyze with the steel, you remember, with iron in previous episodes. Now we are going to analyze uses of carbon fiber. Carbon fiber is commonly used in textiles, aerospace, civil, military, in competitions, and is used in the fabrication of hulls, poles, and in different type of structures. Carbon fiber every day is more popular. It's expensive in comparison with the fiberglass. Right now we are going to analyze, but it's wonderful. Those are the properties of fiberglass in comparison with the properties of carbon fiber. Fiberglass normally can be combined with polyester resin and epoxy resin for fiberglass. However, carbon fiber should be combined basically with epoxy resin. Can I use polyester resin with carbon fiber? Yes, but the final structure is not the best. For that reason, the recommendation is with epoxy. What is inconvenience of fiberglass? is too rigid, is brittle, and the cost is low cost. In comparison with fiberglass, that the problem in comparison with the carbon fiber, that the inconvenience is the high cost. It's too expensive. Is one of the inconvenience. And this is a wonderful table that with the comparison in between fiberglass and carbon fiber, and we analyze the density, the tensile strength, the compression, the surface, the fatigue, resistant to high temperature, resistant to moisture, and we have this is poor, this is excellent, this is poor, this is excellent, depending of both of them. I recommend analyze this table. This table is part of our book of composite materials. You can buy the book in our webpage at www.mrlopezclasses.com. And those are the comparison in between the mechanical properties of fiberglass with the mechanical properties of carbon fiber. And remember that the different type of fibers in carbon and glass. The most common type of fiber and carbon structures are these. In carbon we have the AS4, the IM7, the most common. And in fiberglass we have a S glass and E glass, like I explained before. I am talking about the marine application, don't forget that the carbon fiber structure have an excellent appearance. It's used to cover the final product because it's nice. The appearance, the structure of the carbon fibers covered with the resin and polished after that produce a wonderful surface. Yeah, there are fiber cloths like this. The 3K is a carbon fiber cloth, is a staple carbon cloth, is used in boat builders, in automotive applications. This is the appearance of this. And this is the other one, carbon Kevlar hybrid. Is a hybrid in between carbon and fiberglass. That's wonderful. The appearance is nice, and is covered with the epoxy resin, produce excellent structures. And this is the other one. It's like a tape in a carbon fiber mat. And when you remove the adhesive, start the reaction. When you remove the adhesive, the oxygen enter and start to affect that the catalysts produce, accelerate the reaction, and the surface dry in 2 hours, 3 hours, and you have excellent appearance. It's used in a automotive industry to cover the wheels, to cover frames, and produce excellent external surface. It's coming in different colors and in different widths and lengths, and is impregnated with adhesive. Immediately you remove the paper protecting the adhesive, start the reaction, and the carbon structure dries.